Hello, this is another presentation just taking you through the circles homework this time. So let's get on with it. Obviously, I expect most of you will just fast forward to the question which you're having trouble with. Cool, that's obviously what you should do. But I'm going to start on number one. Now, I'll do one and two at the same time just because sketching each circle, well, it requires the answer to part A, so it seems sensible to do that. Now, the trick here is to always do the same thing. It's complete the square twice. Complete the square on that bit and complete the square on this bit. Now, I haven't completed the square yet. I'm just writing the terms next to each other. I'm going to chuck the 15 over onto the other side of the equals as well. You don't have to do that yet, but it seems like a good idea. Watch out for little careless slips here, but essentially I complete the square, so I halve the coefficient of the x term. So that gives me x minus 5 squared. And the reason why I do that, by the way, in completing the square is because x minus 5 squared would give me x squared minus 10x, because you get x squared minus 5x minus 5x. You see, you get x squared minus 10x, but you also get a plus 25, which you don't want. And that's why we always take away that squared. Yeah. Now that, if you multiply it out and simplify it, it equals this bit here. And that's the idea. And the same once again here, y plus 3 squared. So I'm halving that term, putting it in a bracket, putting y plus 3, because that would give me y squared plus 6y. But it would also give me plus 9, which I don't want. So I've got minus 9 there, equals 15. And then it's just chuck everything onto the other side. And you can immediately identify by sight then the center and the radius, because 15 plus 9 is 24, and 24 plus 25 is 49. Okay, as we've got the general equation of a circle, and I probably should mention this, this is what this homework's all about. X minus a squared plus y minus b squared is r squared. That's for a circle, center AB, and you want to know this like inside out, radius r. Yeah, so that's like your y equals mx plus c for a straight line. It's describing the general properties of a circle with a center AB and radius r. You can always write the equation out like that. Okay, so what's the center here? Change the signs, 5 minus 3, and the radius is 7, because 7 squared is 49. What would this look like on a graph? It's going to look like, well, it's going to be a 5 minus 3. Now, what? Keep careful here. It's going to be actually a bit more difficult. It's going to be at 5 minus 3. Now, we want to decide whether the circle like is beyond the origin or before the origin. Well, if I did 5 squared plus 3 squared, I get like and square root. I get root 34 for the distance from the origin to here. And the square root of 34 is smaller than 7, because the square root of 49 is 7. Hence, I know that the circle is going to be coming outside like that. It's a terrible picture of a circle, I know. I'm not very good at art. Let me try again. Here it goes. Oh, look, this is perfect. This is absolutely perfect. There we go. Smashing. And that's it. Stick your Y on and your X on. Don't be too lazy. And there we go. We've got 1A and question 2 for 1A done. Okay, it works no different than 1B. This first question is very much a basic techniques question. You're practicing the basic skills. So make sure you can do it. X minus 3 squared minus 9 plus Y minus 4 squared minus 16 equals 0. So we're going to get x minus 3 squared plus y minus 4 squared equals 25. And so that's center 3, 4, and r equals 5. So when you're drawing this, the interesting thing about this one is it will go through the origin. The reason it will go through the origin is because it's at 3, 4, center. But the distance from here to the point 3, 4 is a distance of 5, because 3 squared plus 4 squared square rooted equals 5. Hence, I know that my circle is going to pass through the origin. Sorry for drawing it over someone working there. That's supposed to be passing through the origin, and that's what the circle is going to look like. Make sure you can show that it's passing through the origin as well. Now for the last one, probably the hardest one because it's got these pesky 4s here on the x squared and the y squared. Different approaches exist here. I'm going to divide everything by 4 because I'm a coward. I've always been a coward. It's just the way I am. Minus 4y, 22 divided by 4. Almost wish I hadn't done it now. 5.5. well, we could write it as 11 over 4, I guess, because it's 22 over 4. Sorry, 11 over 2. Because it's 22 over 4, that's 11 over 2. So I've just divided everything by 4. And then I'm going to proceed as before. And I'm going to have some decimals here, but I prefer not to work with decimals. So I'm going to work with fractions, because fractions are your friend. They really are. It's easier to work with fractions. Look, a half of 3 is 3 divided by 2. See, it's like a cheat. And what's 3 over 2 squared? Well, what's 3 squared and 2 squared? It's 9 over 4. Same with the y's, y minus 2 squared, but then we're going to be taking away 4, and then we've got plus 11 over 2 equals 0. So if I continue down here, I'm going to have x plus 3 over 2 squared. I'm going to have plus y take away 2 squared, and it's going to equal, now if I write that as 16 over 4, and that as 22 over 4, should have left it over 4. I've got minus 9, minus 16, which is minus 25, but then plus 22, which is minus 3 over 4. So when I add it over to this side, I'm going to get 3 over 4. And hence the center is minus 3 over 2, 2, and the radius is the square root of 3/4, which is, if you like, root 3 over 2. What does that look like on a sketch? Let's have a look. It's going to look like this. We've got center minus 3 over 2, 2. Make sure you get it in the right quadrant. And then as the distance from minus 1.5, if you like working with decimals here, we do 2 squared plus 1.5 squared square rooted. We find that distance there. And that distance is greater than root 3 over 2. Hence, you're going to have a little circle like this. Put your x and y on. Oops, I didn't on the last one. Bad, Mr. Nichols. There we go. X and y. So that was the first question. The diagrams are normally where people lose marks in these ones. Like and it's just the odd mark, but you know, do think about it. Okay, right. Next one. What do we have? We've got a circle, center 2 minus 5, radius 3. Find the Cartesian equation. Dead easy. We know it's going to be x minus 2 squared plus y plus 5 squared equals r squared, which is 9. You can just write that one down. I'm guessing almost everyone will get that right. You might make a slip on something on signs or something, but that is a Cartesian equation as well. Cartesian equation just means x's and y's involved with the equals. Yeah, it's an equation, so it's got equals in it. It's Cartesian because it's all in terms of x's and y's. It comes from the French philosopher René Descartes. If you're interested, he came up with Cartesian coordinates. So there we go. He came up with lots of stuff as well. Okay, yeah, and if you do RS, you might hear about his argument about, well, he's got lots of philosophy arguments. Anyway, I'm waffling. Okay, a circle has center 1, 7, diameter root 8. Find a Cartesian equation of the circle. And we're going to leave it in this form. Okay, well, it's x minus 1 squared plus y minus 7 squared. Now, be careful here, because we're going to have to make this root 8 over 2 for the radius, and then we're going to need to square it. I've divided it by 2 because this is the diameter. Half the diameter, you get the radius. Now, that's going to give you, after you square it, 8 over 4. So it's actually 2. And so we've got x minus 1 squared. In fact, I might start multiplying these out. This is the same as x squared minus 2x plus 1 plus y squared minus 14y plus 49 equals, like I say, 2, because you've got square of square root of 8, which is 8, and the square of 2, which is 4, and 8 divided by 4 is 2. And so in the end, you'll get x squared minus 2x plus y squared minus 14y. Well, as that's 50, take away 2, you've got plus 48 equals 0. And that's the end of that one. I hope that one makes sense. Now, number 5. And I reckon you'd probably be all right in these. I'm probably telling nobody the answer here because I reckon you've probably got these right. The point A is coordinates 2, 5. Point B is coordinates this. Find the equation of the circle. And these are diameter. So we need the midpoint. Because the midpoint will be the middle of the circle. The midpoint is 0, 6.5 or 13 over 2. Yeah. So we're going to have x squared, because no point in doing x minus 0 squared, plus y minus 13 over 2 squared equals, now, I suppose we should find the distance from here to here for the radius, and that distance is going to be, the distance squared, in fact, is going to be 2 squared plus, now 5 minus 6.5, or 6.5 minus 5, well, that's 1.5 squared. And therefore, that equals 4 plus 2.25, which is 6.25. And that's what they want for the radius, isn't it? That's already the radius squared because it's a distance squared. If you want square root it, you get 2.5, but then you're going to square it again, and you're going to get 6.25. And so if you've written it as a fraction, that's 25 over 4. Cool, going good. So what we got next? 6. Write down the coordinates in the center of C. So same old, x minus 3 squared minus 9 plus y plus 4 squared minus 16 minus 75 equals 0. Now, if we look, that's going to give us a center of 3 minus 4. And the radius, well, as you add it all onto the other side, you're going to get 100, I think. Looking at that, plus y plus 4 squared equals 100. And so the radius is 10. Okay, a second circle has center at the point 15, 12 and radius 10. Sketch both circles on a single diagram. Let's give it a go. Find the coordinates of the points where they touch. Touch in maths normally means that they are just like a tangent at that point. It's not the same as intersect. It means you get like repeated roots and stuff like that when circles touch. Now, our first one's like at 3 minus 4. And our second one's at like 15, 12. So we've got circles here and here. The reason why they touch, by the way, I can see that they touch because if I find the distance between the centers, I think the distance is going to be 20. And as one's got a radius of 10 and another's got a radius of 10, they must touch, if you see what I mean. Like, say, here. This is a point 15, 12, by the way. And that's a point minus 4, 3 minus 4. On here makes it a bit longer. Scribble that out. Okay, X there. Sorry that my diagram's a bit messy. I haven't drawn the circles yet, but they're going to look like this. But I want to quickly explain why I can tell. That's a shocking circle. Why I can tell that they touch. They told me that they touch firstly, but I can also tell that they touch because this distance here is 20. And if that distance is 20 and one's got a distance of 10 and the other one's got a radius of 10, they must touch, if you see what I mean. Now, how do I know that distance is 20? Because if I'm looking at the gap from 3 minus 4 to 15, 12, then that distance is going to be equal to the square root of 12 squared plus 16 squared. So that's 144 plus 256. That's root 400, which is 20. And that's how I know they touch. And there we go. Now, how can I find the coordinates where they touch? Just realized I haven't found the coordinates. Well, this is lovely. I love doing this via vectors. Let me show you it via vectors. We know that going from 3 minus 4 up to 15, 12, we need to go in this direction. I'm going to work on it now. Oh, God. Sometimes my whiteboard doesn't quite do what I want. Let me draw it out again underneath. We know we need to get like this. Sorry, it's just taking a moment. Okay, so if we're going from 3 minus 4 to 15, 12, and I want to go halfway, well, this is just a vector argument. That vector is 18, 12. And then from minus 4 up to 12, you've got 16. Half of that will be 6a. And therefore, if you add 6 onto this, because really what we're doing is we're going up 12 across, sorry, up 16. Sorry, I'm getting these the wrong way around. We're going across 12, up 16. Well, to get to the midpoint, just do half of that. Just go up 8 across 6. So in other words, we need to increase this by 6, giving me 9, and increase that by half of 16, which is 8, giving me 4. Yeah? Basically, it's the midpoint as well. Maybe I should have just described it as a midpoint. It's the midpoint of those 2 points. Of course, it's the midpoint, but it's because of vectors that midpoints work like that. Okay, let's do the next one. 7. Is this the last one? Oh, this does go on a bit, this homework, doesn't it? Okay, so what we got here? Circle C, center AB, radius 5, touches the x-axis of 4, write down the value of A and B. So they're saying this should be obvious, and in some ways it is. If it's got a radius of 5, then B is definitely going to be 5 up, because the radius is the same all the way around. So that's going to be 5. Oh, it's right down as well, so you don't have to show any working. What's the A coordinate? Well, isn't it just written for you right below it, 4? So that's going to be 4, 5. Nice. And now we've just got to find the Cartesian equation. So x minus 4 squared plus y minus 5 squared equals, radius is 5, so 25. Done. And lastly for C, now C is a difficult bit. This is a bit where you need a little bit of like, you've got to write on a diagram. Remember, you always, you can always own the diagram. It's yours to annotate. It really is. So we've got a tangent to a circle drawn from the point 8, 17. So that's like somewhere up here. And it touches the circle at T. So I'm going to draw it touching this. Oh no, hang on. I'm just going to have to draw it by freehand, which is always dodgy. Oh, this is pretty good actually. So here's a tangent from this point touching the circle at T. Now we don't have to find the coordinates of T here, do we? No, we've got to find the length PT. Now here's P, here's T. Now we already know, remember, that this is 5, 4. Is it that way round? 4, 5. There we go. So we already know that's 4, 5. But if you were to construct a right angled triangle there, and why do I know it's a right angled triangle? Circle theorems. What I can do now is, I know that this side is length 5, because that's a radius. I know the length of this side, or at least can find it, because it's the distance between these 2 points here and here. I hope you don't mind me doing it in my head. 17 squared minus 5 squared is 12 squared. 4 squared to, well, from 4 to 8 is 4, so gap of 4, we need to square it. So that's going to be root 16 plus 144, so root 160. And so if I want to find the length of PT, I'm going to need to do, now I've got, a right angled triangle. That's 5. That's root 160. And I'm being asked to find x here. So I'm going to do that squared minus that squared square rooted. X equals the square root of 160 minus 25. And that comes to the square root. In exact terms, it would be the square root of 135. But the square root of 135 is 11.6. It's a pretty sig fig. And that's all there is to it. Okay, number 8. What have we got for number 8? Oh, right. Okay, I hope you remember these circle theorems. The fact is, if you ever draw a chord on a circle and find its perpendicular bisector, it always passes through the center. That's an interesting fact about circles. Now, this waffle just tells you basically what you see in the diagram ahead of you. So we've got to find the equation for L. So we need the midpoint. The midpoint is going to be the middle of 3 and 5, which is 4. Middle of 7 and 1, which is 4. So the midpoint's at 4, 4. Now, what else do I need here? I need the gradient. And the gradient of AB is going to be, that's going 6, and that's changing by 2. This is sometimes how I do the gradient, especially if I can see the points. I just think, how much has Y changed? How much has X changed? Change in Y goes on the top, change in X goes on the bottom. And then I just stick in the minus sign because I can see that that's negative. So I can see that gradient's minus 3, which means the line L has gradient 1/3, negative reciprocal. So now I can just do Y minus Y1 is M times X minus X1. That gives me Y minus 4 is 1/3 times by X minus 4. Now in these situations, that gets you full marks because it's just an equation for L. Not the equation for L, an equation for L. A and an is called the indefinite article, I think, in English, and it just means that you're not being specific. And so you can give any equation for L there. Cool, that one will do. I can't be bothered to tidy it up. If you do tidy it up, by the way, it's 3y plus A equals X plus A. If you can be bothered to tidy it up. But I must admit, I'm supremely lazy, so I don't bother where I don't have to. Right, we need an equation for the circle. Oh, okay, we know the x coordinate C is minus 2. Well, we can find the y coordinate now because if x is minus 2, this is going to be 6, and therefore y must be 2. And I've just found that by plugging in the x coordinate into the line L, because I know it's minus 2. And now I can do it. I've got x plus 2 squared plus y minus 2 squared. I also need the radius. That will be the distance from here to here, which I'm going to casually work out in my head again. The radius is going to be, I won't do it actually, I'll do it properly. Square root of 5 squared plus 5 squared. So that's like root 50. But that means it's going to equal r squared, and that's going to be 50. Therefore, we've got it. Oh, find the area of triangle ABC. Finally, an interesting sort of question. It's going to make us think a bit more. Okay. If we work out the distance from C to M, and remember we've got the coordinates of M because it's 4, 4, then we've got the perpendicular height. We need the base as well, and then we can do half base times perpendicular height. Now, the distance from CM, well, that's going to be the square root of 6 squared. I'm changing by 6 there, so 6 squared plus 2 squared. That's going to be root 40. Right, the distance from AB, well, that's going to be square root of 2 squared plus 6 squared. Oh, we get root 40 again. That's interesting. That kind of shows us, yeah, it's a nice sort of squarish looking triangle in its height as well. Okay, right, so the area is going to be a half times root 40 times root 40. And if you ever get a square root times by itself, it equals what's in the square root because you're really doing 40 square root squared. And so that's 40 halved, which is 20. Oh, and I think it was in centimeters, is it? I don't know. Is it? Let's have a look. No, it doesn't say, so we just say 40 units, 20 units squared. Done. Okay, I hope you enjoyed that, and well done. And yeah, let me know if you've got any problems with it. All the best. Bye-bye.